everybody, and welcome to this episode of Boss Level. My name is Chris Melissinos. I'm the Principal Evangelist for video games here at AWS, and today we are going to be talking about using Graviton for games. And as always, I'm here with my panel of experts. Please, guys, introduce yourself.
Tim Bruce, I'm a Senior Solutions Architect in AWS Games.
Hey everyone, I'm Dominic Mills. I'm also a Senior Solutions Architect for games.
Hello. My name is Gabriel Batista, and I am the Solutions Architect for AWS for Games.
Hello, everybody. My name is Karthik. I'm a Principal Solution Architect in AWS.
Awesome. All right. Thank you, guys. Now, look, I mean, we're excited to go in and jump in and talk about this. You know, some of our customers may have heard of Graviton and heard claims of the improvement, right, in price performance of using Graviton over x86-based compute. But many may not be aware of what this is or why they should use it, how they would go ahead and get started using Graviton within their own architectures. So this topic is going to serve as an introduction to what Graviton is, what you should look out for when adopting Graviton and common game workloads, right? That would be really good candidates to use Graviton. But before we do that, I would be remiss if I didn't ask, what the hell are you playing? We're going to start with the last panel member here to chime in. Karthik, what are you playing right now? What is absorbing your gameplay time?
Well, right now I'm playing I think they reintroduced a game that was in the 2004 version of Nintendo platform called F-Zero 99. So they have it on Switch Online right now. That is one addictive game. Think of it as a forefather of Mario Kart. I think Mario Kart came a year later or a few years later. I could be wrong on that, but F-Zero 99 is what I'm playing.
Awesome. Yeah. Original F-Zero was one of the first Mode 7 games, right? We would lay it down. But now you get to play with 99 players in an elimination race, right?
It's chaos.
I know. They've done a really wonderful job of doing that with, they did one with Pac-Man. They did one with Tetris as well. Really fantastic. And highly addictive. Yeah, I agree. That's a good one, man.
I really was expecting you to say Nintendogs when you were finishing that sentence. I don't know why, but that's what I was expecting to come out of your mouth.
Oh, that's awesome. All right, Gabriel, what's got you going, man?
All right, so I recently coughed up the cash to get a Steam Deck, and I am absolutely in love with this device. It completely took over my life, and I've been playing Days Gone. It was a game that didn't really get amazing reviews when it came out, but it is so good. The story just grabs you, and the way that they deal with zombies in that game, they almost treat the zombies like a fluid, right? So it doesn't matter where you are, what you're doing, the zombies will pile up against the wall, DayZ style, to get to the roof if you're there, and it's super good, and it runs buttery smooth on the Steam Deck. So I'm just loving revisiting that game.
Yeah, awesome. Steam Deck, I think, too, probably one of the best Gen 1 pieces of game hardware I've played with in a long time. I absolutely love mine. It's taken over a lot of my traditional PC gaming, too.
Yeah, I'm wondering how it's going to compete with the Switch 2, assuming that, it's announced and it comes out. Because honestly, I just bought this and I'm like, I want the Switch 2, but I don't know if I'm going to get it. The Steam Deck just fills that void for me.
Yeah. Yeah, no, it is pretty incredible. Awesome. All right, Dominic, how about you, buddy?
Well, I've been known to play Magic the Gathering once or twice. So the new set just came out recently. So I've been doing some drafts on Magic Arena, and I've been having a blast with that. It's just something that I can go back to, every 3 months. I know there's going to be a new set, new limited format, and I'm just going to enjoy it. So that's where I've been spending my time lately.
Excellent. Always good to go back to the comfort stuff, right?
Yeah.
I can't see Dom with a deck, though. I mean, I don't know.
A Steam Deck or a Magic Deck?
Magic.
Oh, really? No. I'm a huge TCG player. I started with Pokemon and, way back when it first came out. And I feel like I'm one of the only people I know that actually played the game. Everyone says oh yeah, I collected the cards. I'm the only nerd who was actually learning the rules and playing the game.
Oh man. Well, awesome. All right, Tim, how about you, buddy? What are you playing?
So I recently took the dive into PlayStation 5 with VR, and Gran Turismo 7 with VR and a wheel is just insane. I don't think I can go back to a driving game without VR and a wheel at all.
Are you saying we don't need to buy a Porsche? We can just play in the game?
There you go.
Man, so as a former Porsche 911 owner, I can tell you how close that is to actually being in the car. It really is nice. Now, ask my wife how she thinks I drive after I play the game, and that's a different story.
Oh man, yeah, that's awesome. I've heard great things about it. I had the original PlayStation VR headset, didn't move to the 2 just because I had already had a Quest 2, and Quest 3 is definitely on the horizon. But no, it's good to know. I mean, their technology is pretty awesome in the new headset, so
Yeah.
that's really good to hear. Yeah. And then for my part, look, I just did an episode on this a week ago on the Pico 8 environment, and that's what I've been messing around with right now, and I freaking love this thing, right? You're basically scripting in Lua, and this little environment comes with, your editor. It comes with the runtime. It comes with sprite editor, map editor, audio tracker, and sound effects tool. And it's amazing what people are doing in 32K of basically bytecode. Like it's insane, absolutely insane. So I'm having a blast going through and seeing how people are making like sprite scaling engines and 3D engines and stuff. Just having a blast doing, that kind of programming back in this micro formula. And as I was telling the guys here before we started recording the episode, I'm going back and I'm rebuilding the very first game I ever wrote on the Commodore VIC-20 when I was like 12 years old, called Space Debris. So I'm working on that, and I'm going to go ahead and release that too. So we've just been having a blast, absolute blast. So, all right. So that's it. That is what we've been playing right now. And now we're going to go ahead and jump straight into talking about Graviton. All right, guys. So what is Graviton? Why don't we start there, right? Some people may have heard about this. Others may have not heard the term before. Can somebody please share with our audience, what is Graviton?
Yeah, I can start off for us. So Graviton is an offering provided by AWS that is essentially using the ARM chipset architecture. So a few people may have heard of ARM before. It's you probably have it powering your personal mobile device. And doing this episode, I kind of was curious because I knew about Graviton, I knew about the benefits that it gave, obviously being an AWS SA, but I didn't really know like what the origin story was. So I wanted to go back and like do a little digging. And ARM is really this implementation of the reduced instruction set computer. RISC is probably how you'll hear it. Mm-hmm. And you can kind of compare that with the CISC, the complex instruction set computer. And really the difference is the complexity of the instructions that are being sent to the CPU. That's the big difference, right? At a fundamental level. And with these reduced complexities, you get these benefits in terms of power usage, like the amount of energy that is being wasted, like thermal generation, right? So they're a lot cooler, so the power consumption is lower, and it's actually lower to manufacture as well. So all of these things kind of help point it to being more efficient and lower cost, which is why they're so common in our mobile devices. Mm-hmm. One of the cool things that I found about this is, okay, so Graviton is based on ARM, right? ARM is based on RISC. Games has this awesome legacy of using ARM and in general, like RISC architectures, and it's very easy to find, but you've got your Androids and iPhones, which are ARM architecture, but did you know that like the Game Boy Advance was also ARM, the DS, the Switch? Those are all ARM devices, which is super cool. And if you look outside of ARM, things like the IBM Power PC, which is also based on the RISC architecture, powered the GameCube, PS3, the 360, other things that are RISC based, PS2, PSP, N64, like all of the greats, all the great consoles are all ARM based. So I think that was such a cool moment for me, is like looking back and being like, oh man, like ARM and games, they've just been tied together from the very, very beginning. So it's really cool to see that expand into the cloud too, and see now games customers adopting ARM in like this new way, right? With the innovation of the cloud.
Yeah, and I mean other platforms, of course, too, like Hitachi's SH2 platform,
Yes,
right?
yes.
The Saturn, but then the
And
Dreamcast eventually used it too.
Mhm.
And being an old Sun Microsystems guy, of course, all the stuff we did in Spark and Ultra Spark was all RISC-based, right? So you get all those efficiencies you talked about, right? Simpler instruction set, lower cost, lower power consumption, lower heat generation, and that translates into lower cost in terms of operating it, but doesn't sacrifice in terms of performance. So if you go ahead and port to that platform, you can go ahead and basically get the equivalent performance you would get on traditional x86 instances, but get all those other benefits in terms of cost reduction. And that is passed on to the developer that's running on Graviton on AWS, right?
That's exactly right. Yeah.
Guys, weigh in here. What else do you want to talk about with regard to the ARM architecture and what Graviton is, and maybe talk a bit about the offerings that we have here?
I mean, I guess the first place to start, I think where most people will look when they immediately say, okay, I want to use Graviton, where do I go, is EC2, right? Elastic Compute Cloud. We have Graviton instances in different families, different sizes, very similar to our like x86 based EC2 instances. So I think that's immediately where game developers' minds go when they think of adopting Graviton. But I think actually there are easier ways to adopt Graviton if you want to get those benefits that we've been talking about, right? I know Tim has worked with some customers on this, so I'm curious to hear his take.
Yeah, definitely. So we have a service named Lambda. Basically, it's functions as a service. You upload your code to the cloud. You set some parameters like, I don't know, platform. Instead of x86, you choose ARM. And boom, you're up and running on Graviton 2 for your functions as a service. There are some nice things about Lambda. We do have some runtimes that we support natively. So you don't have to worry about anything like the operating system or libraries that come with it. You just use one of those runtimes and you're off and going. Really kind of cool. And I know, Karthik, you have some other experience too.
Well, I was saying, before we jump over to Karthik, so when you talk about the platforms, let's make sure we hit on those. Like, what does Graviton 2 support, right? And how is it also different between Graviton? So what's Graviton 2 versus Graviton? And let's talk about the runtimes that Graviton 2 supports.
Yeah. So actually, I think there's 4 versions of Graviton that are now released. So we have the original Graviton. Graviton 2 was the 2nd generation. Graviton 3 is the 3rd generation. That's pretty popular in terms of instance usage right now. And then Graviton 4, which was just announced at reInvent.
Yeah. So the first Graviton 4 instance.
Gravitor. That was a discontinued Transformer or GoBot. Gravitor. So we never used that. So we chose Graviton.
That's me. That's my costume for next Halloween. Anyways,
Gravitor.
The first Graviton 4 instance is the RAG, and if previous generations are anything to show, that that'll start rolling out across like multiple instance types and families and managed services like Lambda, right?
Yep. And so on the Lambda side, right now it supports .NET 6, Python 3.12, Node 20, Java 21, Ruby 3.2, Go 1, and those are at the latest versions. So there are earlier versions that are supported, but if you're developing something new, you probably should go to the latest available runtime for Lambda. That'll give you more runtime for how long you can stay on the platform and use that same version. We also, on the Lambda side, are announcing new updates coming out in 2024 on the Lambda update page. So .NET 8, which is very popular with our game tech customers, is going to be supported, currently planned for this month. February 2024.
I should also add in that for those who are in doubt in terms of how to migrate their existing workloads, AWS provides the AWS Compute Optimizer service, which is it's a totally free service you can turn on in your console. You let it run for about 12 hours, let it take in your environment. And what it does is that it gives you suggestions on workloads that you can right size first and foremost between the different EC2 instances that you're using, but will also tell you what workloads are supported by Graviton, and will give you some suggestions on how to port those workloads to Graviton. One interesting point here, if you're going to do that, is that the migration suggestion is based on instance tagging, which is a best practice. We try to let our customers know it's always great to tag as many of your resources as possible, because services like this are able to take a look at it, assuming that you have a tag with the key application type. And let's say you're running Hadoop. You tell it that, hey, application type value Hadoop. The compute optimizer that will actually be able to pick up on that and give you some information on how to get that migration done and how difficult it would be.
Yeah, that was going to be a question I had. When you're looking at wanting to leverage the advantages that a Graviton instance can provide you, if you're working with a really complex build, you're not quite sure how you're going to be able to migrate over. The compute optimizer basically highlights the things that will work, the things that won't. So you have basically a map, right? Or some guidance for what you need to do to make your application or your environment run on Graviton, correct?
Yeah, absolutely. And on top of that, if you happen to be running an application that the compute optimizer is not familiar with, or does not have any kind of suggestions on guidance on making the migration,
it just throws up Karthik's phone number. Is that what it does?
Yes, exactly. Or
call
either Karthik or the compute optimizer feedback at Amazon.com. That's the compute optimizer team is actually really interested on anybody trying to migrate applications to Graviton, and they help build out the guidance for you.
Some of the customers actually who did try Compute Optimizer, we've seen that, yes, we get feedback on how to be optimized or what instance types to leverage. We've also seen like predating Compute Optimizer. We have seen customers even use Trusted Advisor and some of the data you get in Trusted Advisor as a mechanism to see, hey, what instance types can be better for certain workloads that have been running in their ecosystem. So we've seen like data from Trusted Advisor, and also some of the data we get from Compute Optimizer. We need to make sure that we validate with like a more detailed POC gate, because what we've seen with some customers is the applications they tested were not at optimal peak capacity. So when they actually did a load testing on the underlying application, it gave out different suggestions versus when it was run-of-the-mill steady state traffic. So that was one of the guidance we gave to customers testing with Compute Optimizer is, sure, like, in your steady state workflow, you have a data type, but what about when you're under stress or when you have a high amount of TPS coming in, right?
So yeah, absolutely. And you know what? This is why the account teams are here. This is why we work here as solutions architects, right? Anytime you're doing work like this, please reach out to us. Let's do a demo. Let's do a proof of concept, right? Let's test this thing out before it goes into production, so you can feel confident in the performance you're going to get out of the machine.
Okay.
Tim, that's so interesting, Karthik. I wanted to ask, so I don't even know if we mentioned yet, but when you go from generation to generation in Graviton, essentially each generation has been this price performance improvement over the previous one, right? And I'm curious, since those previous generations are still available, like instance types, and you can select them as options in managed services. I'm wondering about spot pool availability for those older instances. And, given that most people are trying to go onto the new one, I wonder if the spot instances of previous generations are pretty wide open. And for scaling events like what you were talking about, Karthik, if those would become more valuable as, you're scaling up and requesting more instance types. It's cool that Compute Optimizer kind of catches that.
Yeah, the spot instances is a slightly different ball game though. So when we have lifecycle policies within our data centers, right? So as we get through 1, 2, or even 3 new generations of let's say instance class, the underlying parts to support the few generations older infrastructure, it gets slimmer and slimmer. So as customers migrate away from that spot pool, or they're not using it for a certain amount of period of time, the system doesn't even show. Like if you go through CLI and actually check for one instance types available for that particular cluster, it doesn't even show you the old instance types because they're on the path to be decommissioned because they're 3 or 4 generations older. Like in the non-spot scenario, we have customers who hold on to their hardware even like many years past. We've moved on to like many generations of instance types. But even then, like the EC2 team does notify them saying, hey, this is very old hardware. Please come on to the newer one. Here's the benefits for it. Here's it's N percentage more cheaper with being more efficient. And that again goes back to the point that Gabe made, which is work with your account team, your solution architect, to see which one is the right instance type for you. If you haven't done any evolution in a while, it means it's time for evolution within your underlying infrastructure.
Yeah, one thing I'd like to add to that too is thinking about the libraries that you're using on ARM or planning to use on ARM, right? So not everything is compiled to operate efficiently and effectively on ARM. There are some things that are optimized for x86 that you might be running. Another thing that we can do as solution architects working with you is help you understand what can be run on ARM and what can be run on ARM effectively. We also have a GitHub repo that talks about things that we've tested. We have a whole team of SAs that focus on just looking at ARM, what libraries work on it, whether it's Java, Go, Node, Python, Python C, really trying to help customers through that problem. So not everything that you're running on x86 will be able to run on ARM or will be able to run effectively. So be aware and look at that first before you make any plans to even begin moving to ARM.
Yeah, and I guess part of that too is also knowing what the price performance delta may be from moving from x86 to ARM, right? Using like Lambda power tuning. So you want to talk about that real quick?
Yeah. So I had a customer that actually moved to Graviton 2 immediately once we released it for Lambda. They were kind of very well set up. They knew what was coming. They were able to look at their libraries, determine that, hey, everything is working on ARM before they even got a single instance of Lambda running for Graviton 2. Worked extremely well. They were able to go through with power tuning on top of that migration. And they noted like, hey, we can actually like reduce the memory settings a little bit. They actually ended up increasing the memory settings long-term after they did a load test because they actually wanted the performance that the higher memory settings in Lambda gave them, but they were able to initially cut back on memory because of power tuning.
Yeah. Well, here's the question. Even when they had to increase memory, there was still a cost savings without sacrificing performance that they wound up taking advantage of.
Yeah, well, right. So they were able to get more performance even by going up, right? And still were able to save money versus where they were initially. I've had other customers, however, that they kind of jump in and start seeing what's happening with ARM, and they haven't had such a great time because they didn't go back and look at like what is running on ARM and is what we're doing ARM compatible. So that's a really big piece. Like make sure you know what is going on, what you have in your inventory before you start considering this path.
Yeah, I'll share one story from one of my customers who's sort of like a prime success case, I guess, in that, which is we mentioned Graviton to them. Maybe a week later, I checked back in with them. I was like, oh, hey, did you look into Graviton anymore? Do you think this is something that you'd be interested in? And they said, oh, we already migrated like all of our CI/CD pipeline over to Graviton. So when you're already using, software and libraries that work on ARM, the migration can actually be really quick. I was blown away. They're like, yeah, we switched over. We're already using it. I was like, awesome.
Oh, I love that.
Yeah. I love that,
especially when when the process was seemingly straightforward enough that they didn't have to come back for that help, right? That they were able to use the resources that we made available to them and do that migration on their own. So the fact that it was like, we did it. Don't even know if we need to let them know that. That's awesome, right? That a developer can do that. But let's say that this is all new to you. What should developers be thinking about if they want to really eye an ARM-based architecture for the future, again, to be able to take advantage of the investments that AWS is making in that architecture, that infrastructure? Like, what are some of the tips or tricks that developers should really be thinking about if they're going to be eyeing, again, an ARM architecture for the future?
Some of the lowest hanging fruit we have, Chris, is there are many managed services that offer Graviton instance type in the offerings they have. So, for example, we have Aurora or RDS, relational database services that we have, or the Aurora managed platform for databases. Both these database offerings have Graviton instance type as an option for customers to adopt and get benefits of Graviton from the get-go. So there's no need for any code rewrite. There's no need for any application rewrite. It's just a different instance type that's denominated with a G at the end of the instance family type. So it's R6G or M6G or M7G. So the G is denoted for Graviton. So we have many services, not just databases, but we also have caching solutions that offer Graviton instance types. We have our streaming services like managed Kafka service that also has Graviton that was announced at reInvent. We have our data warehousing platform, EMR, that also offers Graviton, and Lambda and Fargate, we talked about it earlier. So those are the low-hanging fruit for customers to get immediate savings within their infrastructure by adopting Graviton. One more point, and to Dom's earlier point on CI/CD, for them to continue using their existing CI/CD stack, there's no other code rewrite they need to do, because like Dom said earlier, it's just an instance family that they need to choose in the Terraform or CloudFormation script and then update it accordingly. And that's it. There is no other thing that they need to do. They can get the ball up and running and start using Graviton.
Okay, so look, the way I'm looking at it now, if I'm a developer listening to this right now, I'm running on AWS, love AWS because they take care of everything that I need to, just like they always say they do. But there's an opportunity here now for even greater cost savings. It's, supports, again, runtimes like .NET, Python, Node 20, Java 21, so on and so forth. Do we have guidances or recommendations on how to go ahead and migrate your application to a Graviton instance? We have code samples and stuff on GitHub. We have an analyze that will tell you what will work and what doesn't work. Like, what are we missing? What do we need to help developers understand?
We actually have one more thing out there. So there's a great blog post about how to compile your Unreal game to ARM. Yeah, how to make it run on Graviton.
Yes. Yeah, and we'll make sure that you have access to that link in the show notes for this episode. So absolutely. But okay, with that one.
Question on that. Sorry, I have a question for Tim.
Go.
Tim, on that question on rewriting Unreal code to support ARM, there's a delta, like at least with some of the customers that I'm speaking on, let's say they have a game that's really popular, that's 13 or 15 years old. And now what is the delta that they need to calculate to rewrite a 15-year-old game to support a big chunk of players that they have, to even go down the journey? Like when we go to customers, or when we went to those customers and said, hey, you can use ARM and for all these things that you did 15 years ago, they're like, it's a 15-year-old game. Do we invest time and energy in modifying or rewriting stuff for a 15-year-old game, or do they invest the same time and energy for a new game that they're going to launch in the next couple of months or years? Like, have you found the delta before?
I have seen that delta, and most game customers who have that 15-year-old game, or even a 5-year-old game for that matter, are just saying like, hey, it's running. I'm going to leave it running.
Right.
Might not be worth the investment. But somebody with a game that might be out there a year, that might be something that they consider, right? Because they're thinking about that long term.
Yeah. I mean, look, and the reality is that game development is not getting any cheaper.
Yep.
So anything that we can do that helps developers still maximize performance, maximize reach, but decrease their cost is going to be a better game they can build, more artists they can bring on, more of a game that they can create, right? So Yeah, for the older ones, right? Not only just because they've been running, and so we're going to kind of leave them alone, but then it's also understanding what is the kind of the risk profile of me trying to port an older backend or a game to this architecture and the chance of something breaking. And again, that's where things like, the profiler tool and things like that will help them know what that risk envelope is. It basically, if half their application isn't working, probably not worth touching it. Probably just let it continue going. But right, if it doesn't seem to be that heavy a lift at all, and they can still maximize their cost savings, then there's an opportunity to do so. Oh, we just lost Mr. Gabe, who just happened to disappear from. He was fed up with. In fact, the reason we lost Gabe from the feed was because Gabe decided that he was so excited about porting his own application to Graviton that he has just now exited the podcast so he could go ahead and follow all the links that we're posting.
He's going to start building right now.
He's going to start building it right now. And so now Gabe is popping back in here. Gabe, were you able to leave us and then go ahead and port your application over to Graviton? Is that what you were doing? Because that's what we assumed.
That was exactly it. I was so inspired by all of the value that you get at Graviton. I just couldn't resist.
That's awesome.
And he did it in less than a minute, I think.
Amazing. I don't know. And if you all want to know how he did it, please go ahead and reach out to Gabe. He'll be happy to share all of them. No, but it's good to have you back here, buddy. Thank you for making it back. Okay, so again, guys, what other parting chunks of wisdom or tidbits do you want to leave with our audience today as they are going to start digging into those links and exploring their cloud game development journey on Graviton?
I got a really big one here that I think is honestly criminally overlooked most of the time. So we talk Graviton, we talk price performance, right? It's a lot cheaper. You get better performance. That's all fantastic. What a lot of people don't know is that Graviton instances actually use 60% less energy than comparable EC2 instances. Mm-hmm. So not only are you saving money, but you're also helping the environment and you're helping to lower the load required, right, to be able to run some of these workloads. And all of this ties back to this a climate pledge that Amazon made back in 2019, right? We, as a company, have made a pledge to go to have a net zero carbon emissions by 2040. Back in 2022, we've already reached 90% of our electricity consumed from all Amazon facilities are actually attributable to renewable energy sources, which is really cool, right? So we're really ahead of the curve on this pledge that we've made. And then as a matter of fact, all regions in North America, Europe, and China are already powered by 100% renewable energy, which I think is super cool. And that really puts us way ahead of the curve of that 2040 goal that we set for ourselves. And, I think that at the end of the day, it's something that helps you, but better yet, it helps the environment. I think that's a big thing that people should keep in mind as they're building out their architectures.
Yeah, there is just to add on that, Gabe, there's a bigger software momentum that's happening in this space. So we talk about Graviton with our managed services, the benefits we have with it, price to performance ratio, all the things you said. But there's this other movement that's happening across some of our partners in this space. So we talked about Graviton working with our RDS and Aurora offerings, right? Now we have partners like who own Cassandra or MongoDB or Redis, right? Even they are adopting or offering their tech to run better and more efficient on our platform. Now that's just databases. Now on the DevOps side, it's not just the code software that we have. We also have GitHub or GitLab or Jenkins. We have so many DevOps partners that are also rewriting their tech to adhere to the awesome stuff that we get through Graviton. And the same thing on and the other partners. Sorry, just one last point. And the other partners like Datadog or New Relic or Splunk, Terraform, all these partners, we are building this massive ecosystem of how software services that constitute a customer's footprint in the cloud. All of them are pro Graviton support. So it's that movement that's happening to get more efficient processors and be more cost to performance ratio.
Sorry, I needed to add in Honeycomb there too. On the serverless side, they're a really big partner of ours for observability, and Karthik, you hit that one. I would also add in, like, hey, if you're not sure, reach out. We have a whole team of SAs that are focused on helping customers convert to ARM and Graviton specifically. So if you really don't know where to start, you really don't know what to do, call someone, call one of us, get us working with your teams, and we'll figure out how to actually plan that out with you, so you don't have to go in there blind.
I mean, what a great way to end it, right? So look, if you are looking at Graviton and wanting to truly understand how it can benefit your business, follow the links that we're going to have below here in the show notes. Make sure you go ahead and hit those. Make sure you reach out to any one of our incredible panelists here, right? That can help you on that journey. And look, again, if you're looking to operate on a global platform that doesn't give up anything in terms of performance, but up to 60% more energy efficient, much more cost effective, allows you to go and scale with dedicated hardware or take advantage of spot instances. Dig into those links, discover what Graviton can offer you and how we can help you, again, deliver your game securely, performantly, available all over the world, and provide all those additional amazing benefits directly to your bottom line. Right, so guys, thank you so much for spending time with us this afternoon, talking to us, for goodness sake, about how game developers can leverage Graviton for their games as they go forward. So thanks, gang. We really appreciate your time and looking forward to the next episode of Boss Level.
Thanks, Chris.